Alright, so this practice is about parallel lines and transversals. So in the figure, L1 is parallel to L2, and L3 is the transversal. What is the value of Q minus P? Well, notice how it tells you this angle here is 135, and it also tells you that these lines are parallel, which means that this angle is also 135. Well, these angles have to add up to 180, so 180 minus 135 is 45. So we know that this angle is 45 degrees because it's a linear pair. We want to know the value of Q minus P. Well, Q minus P, Q is 135 and P is 45. So 135 minus 45 is 90. Number 2, in the figure below, we've got our parallel lines and transversal. What is the measure of angle X? Well, we know that X and Y are actually equal because they're corresponding angles. They're in the same location, but in different groups. So corresponding angles, when lines are parallel, are always equal. So the answer is Y. In the figure below, what is the value of X? Again, we've got our parallel lines. If they're inside, they're called same side interior angles, and they are supplementary. So we're going to add those two angles together to equal 180. So X minus 20 plus X plus 10 equals 180. Combining like terms, X and X gives me 2X. Negative 20 and positive 10 gives me negative 10 equals 180. Adding 10, 2X will equal 190, and dividing by 2, X is 95, sorry. So the value of X is 95. Number 4. Given the figure below, line 1 is parallel to line 2. So again, we got parallel, and our transversal is T. We know that X, Y, and R are all equal. We want to know the value of R. Well, in this problem, we know that this is X. Well, this would also be X because they're alternate interior angles. Now, remember a long time ago about the triangle exterior angle theorem? The sum of the two remote interior angles will add together to equal the one on the outside. So R plus X actually adds to equal Y. It's a triangle theorem. Well, if we're trying to solve for R, I'm going to subtract X. So R is actually equal to Y minus X, which is option G. So this involves alternate interior angles as well as the triangle exterior angle theorem. Which rays form the sides of angle ABC? So I'm going to draw that angle, A, B, and C. So the way that you name rays, you start at the end point and go towards the direction. So the first ray starts at B and goes towards A. The second one starts at B and goes towards C. So the rays are BA and BC, which is option D. Next, in the figure below, what does that line represent? Line A is called a transversal, so that is just a vocabulary term. Number 7, in the figure below, we've got parallel lines AC and BD, so these are the parallels. They intersect MN, which is the transversal. Angle MXA is here, and angle MYB is here. What are those angle pairs called? Those angle pairs are corresponding angles. The way that you tell corresponding angles, remember you group them in groups of 4. The upper left will correspond to the upper left, so those are called corresponding angles. Next up, number 8. In the figure below, AB is parallel to CD, so here are the parallel lines. And it also tells you that RS and PQ are straight lines. What is true? G is congruent to Z. So looking at the picture, I've got G and Z. That is not true because those are not parallel lines, so they're not going to be the same. So these are out. Option B, G is congruent to Y. Well, those are on opposite transversals. Those have no relationship. G is congruent to F. G is in the exterior, F is in the interior, but they're not corresponding, so that is also not true. G congruent to X, not true. If it's not congruent to Y, it's not going to be congruent to X. G is congruent to E, that one is true. Those are alternate interior angles. If we cover up this portion of the picture, we can clearly see that. So the correct answer is E. Let's do some review. So the sum of the interior angles of a pentagon is what? Well, a pentagon has 5 sides, so I use the polygon angle sum theorem, which is n minus 2 times 180. So 5 minus 2 is 3. 3 times 180 is 540. So any pentagon will always add up to 540 degrees. Another review. So this practice, remember, is a bunch of review problems. It says, if the perimeter of a square is 24x, what is the area? Well, perimeter means I add all the sides together, and if it's a square, I know that all the sides are equal, so I'm going to divide it by 4. 24 divided by 4 is 6x, so all the sides are 6x. If I'm trying to find the value of the area, I would do length times width. So 6x times 6x is 36x squared. So you want to break it up to find the answer and then multiply the length times width. All right, next problem. If 3 points R, S, and T are collinear, and S lies between RT. So let's go ahead and draw a picture. S lines between RT. It doesn't matter where you put it as long as it's between. The length of RS is 2/3 of RT. So let's put that there for RS. The length of RS is also 48. And then we want to find half of RT. Well, we know that RS is equal to 2/3 RT, but it's also equal to 48. So I'm going to do 2/3 RT equals 48, multiply by 3. 2RT is going to equal 48 times 3 is 144. And when I divide that by 2, the length of RT is 72. So this measurement of the full length RT is 72. And I want half of RT. Well, I just found out that RT is 72, so half of 72 is 36. Option D. I would highly recommend on that problem to draw a picture because it's going to be kind of complicated to do without a picture. When you draw the picture, you can clearly see that those two values, they are in fact the same. So since they're the same, you can set them equal, and that actually helps you solve and finish the problem for RT. Number 12. Points G, E, F, and G are collinear. So I'm going to go ahead and draw a picture. Okay. So to draw a picture, it says that EF, sorry, I'm like trying to practice this problem. So E, F, and G are collinear. It says EF is 8 and EG is 12. Which point cannot lie between the other two? Well, F is clearly in the middle, so that could work. Okay, this could also work. So the full length is 12, so EF plus X would equal 12. So F could be in the center. Okay. Well, if F is here, F would also be here. So I'm going to go ahead and cross that one out. Next, we have this distance. So let's try to put G in the center. Well, if we put G in the center, it says that EF is 8, but EG is 12. That's not possible. I can't have this length to be 12 and then the whole length be 8. So G cannot be inside because that distance is too long. That's longer than EF, so it can't work. Sorry, I was trying to think through that problem, so now hopefully that helped visualize thinking. So the correct answer is C. 13, what is the height of the triangle below, or the height of the triangle is 10. What is the area? Well, the area formula for a triangle is 1/2 base times height. So the height is here. Remember, if the triangle is obtuse, the base is located actually on the side. This 8 is not to be used in area. So 1/2 times 10 times 60. Sorry, I know I flipped that. I put height first and base second. It's okay. 1/2 of 10 is 5. 5 times 60 is 300. The answer is B. The 8 is there to throw you off. You don't need it. Okay, number 14. We've got, again, parallel lines. AB is congruent to AC. That is important. We need to mark that. And we need to find the value of X. Well, to help us on this problem, I see a transversal. If this is 80, so is this one. Those are alternate interior. So this angle right here is 80. Well, these are base angles of an isosceles triangle, which means that this is also 80. So now I have 80 plus 80, which is 160, minus 180 is 20. So I know that this is 20. To help me in this problem, these three angles together form this straight line, which means they have to add up to 180. So 180 minus the 80 minus the 20 leaves me with a remainder of 80, which is the value of X. So this problem involves alternate interior angles, isosceles triangles, and linear pairs. Number 15, in the figure below, what is the value of X? Well, we should know that 2y and y, when added together, will equal 180. Those are same side interior angles. So 2y plus y equals 180. So 3y equals 180, which means that y is 60. Well, if y is 60, 2 times y would be 120. So 180 minus 120 is 60, leaving us with angle X, which is 60. So remember, linear pairs, they'll add up to equal 180 degrees. All right, let's try the next one. In the figure below, we've got u, v, w, x. They're collinear. Ux is 50. So I'm going to go ahead and write that down. That's important. Then it tells you that u to w is 22, and v to x is 29. How many units long is VW? Okay, how many units long is VW? Well, we know that this full measurement is 50. If we go back up here, we have 22 plus something equals 50. Well, 50 minus 22 is 28, which means this distance is 28, because I have to be able to add this distance plus this distance to give me 50. Well, now, to get to VW, if I look here, the whole measurement is 29. I have 28 of it, so this answer must be 1, because 1 plus 28 is going to equal 29. So the correct answer is A, 21. Use your picture, draw on the picture, it will make it easier. When two parallel lines are cut by a transversal, how many corresponding angles are formed? Or how many pairs? So I'm going to draw my picture. I see that there are 8 total angles formed, but as far as pairs go, there's 1 pair, 2 pair, 3 pair, 4 pair. So the correct answer is D. There are 8 angles that are formed, but when I pair those up, there are 4 pairs of angles. So the answer is D. Number 18, what is the perimeter? The clue in this triangle here is that these are both 12, so that means that the sides that they're opposite of are equal. That's the isosceles triangle theorem. So this is also 18. So to do the perimeter, I'm going to do 18 plus 18 plus 30, which gives me 66. Answer choice B. Moving on to number 19. We've got all these parallel lines. Oh, sorry, I just dropped my pen. I have to find it real quick. Okay. All right, so we've got all these parallel lines, and we want to know which of the following statements are true. So we've got these are all parallel to each other, and we've got a 90 degree. Well, if these are all parallel, okay, what that would mean is corresponding angles would tell me that all of those are 90, because upper right, upper right, upper right. They're all the same. So going through, 1 is parallel to 3. That is true. This is a 2 and this is the 3 to help you. Line 2 is perpendicular to line 4. Well, line 2, here's line 4. They are, in fact, perpendicular. Line 3 is perpendicular to 4. That is also true. So it is all of them, option E. So in this problem, whenever you have parallel lines, you can have more than one corresponding angle pair. So we know that all these are 90, and that would then in turn show us that all of them are true. Number 20, O is the center and AB is parallel to CD. That is important. Find the value of Y. Well, to help us find this problem, we should know that all of our angles here, notice how this is X and this is X. That lets you know that those measurements should be the same. Well, since this is the center, this is actually half of a circle. Okay, half of a circle. We know that half a circle, so the angles of half a circle, it's going to add up to 180 degrees. So X plus 70 plus X has to equal 180 because it is half of a circle. X plus X is 2X. Plus 70 equals 180. Subtract 70 to get 110. Divide by 2 to get 55. Which means this angle here is 55 and this arc here is also 55. Well, this angle here for Y, that is a central angle, and central angles are equal to the arcs that they cross. So Y is also 55. 21 and 22, those are actually on previous worksheets, so we're going to jump to 23. The length of the diagonal of a 21 by 28 rectangle is blank. So I'm going to draw a rectangle. 21 and 28. We are trying to find the length of a diagonal, so I'm just going to use Pythagorean theorem. So I've got 21 squared plus 28 squared equals x squared. 21 squared plus 28 squared is 1225. And then to solve for x, I would square root. So the square root of 1225 is 35. Answer E. Anytime you're dealing with rectangles, you're going to probably use Pythagorean theorem. It's going to be helpful to find diagonals or side measurements. Okay, number 24. What two numbers should be placed in the blanks below so that the difference between the consecutive numbers is the same? What we're trying to find out is, based on this pattern, we want to know that everything is the same. So 13, another number, and 34. The numbers have to increase at the same speed. So if I put 19 and 28 in this block, okay, 19 minus 13 is 6. So to get from here to here, I would add 6. To get from 19 to 28, I would not be adding 6. I'm actually adding 9. These numbers aren't identical, so A is out. So now I'm just going to plug in my next choices. Okay, 20 and 27. Well, to get from 13 to 20, I add 7. To get from 20 to 27, I add 7. And to get from 27 to 34, I also add 7. So these are all the same going through, so the correct answer is B. The difference between them is 7, so that's the correct answer. 25, we've got real numbers. X cubed is 729. Then x to the squared plus the square root of x equals blank. Well, to find this answer, I'm going to cube root 729. So in my calculator, the way I get to cube root is I press math, and I pick option 4. The cube root of 729 is 9. So that means that my plain old x value is 9. So when I come here, I get 9 squared plus the square root of 9. 9 squared is 81. The square root of 9 is 3. 81 plus 3 is 84. Option J. Number 26. For rectangle measures 20 by 48, what is the length of the diagonal? So again, I'm going to be drawing a rectangle. I know that my angles are all 90. It's a 20 by 48, and we want to know the length of the diagonal. So again, 20 squared plus 48 squared equals x squared. 20 squared plus 48 squared is 2,704. And then when I square root both sides to find the length of my diagonal, I get 52, which is option F. Remember, rectangles use Pythagorean theorem a lot because it's just trying to test whether or not you remember that. Let's go down and try 27. 27 is just some fancy substitution. Remember, the symbol means nothing, but the thing we do want to remember is that x is listed first, so the number that's listed first is also corresponding to x. Y is listed second, so y corresponds to -3. So to plug this in, x is 5, so 5 minus 2 times -3, quantity squared. So 5, -2 times -3 is +6 squared. So this becomes 11 squared, which is 121. Option A. All right, let's finish this practice up on the back. Number 28. Number 28, the parallelogram with the dimensions are shown. What is the area of the parallelogram? Well, the area formula for a parallelogram is base equals height. Area equals base times height. Well, the height is 12 because it's always perpendicular to the base. And then when you're calculating the base, you actually have to add the 5 and the 15 to get 20. So the area formula is base times height. So 20 times 12 is 240. Option D. Remember, the base goes all the way across, so I have to incorporate the 5 and the 15 to get 20. 29, b equals a plus 3, then a minus b to the 4th equals what? Sorry, oh my goodness, the announcements are on. I forgot that we have announcements, and I can't pause this. So we're just going to continue, and I'm just going to kind of talk through it. So I'm going to distribute my negatives, so I get a minus 3 to the 4th. A minus a is nothing, so I get -3 raised to the 4th power, which is 81. Number 30, we're trying to find the measure of angle CDB. Well, it tells us that we have an angle here that's 100, so that should help us get to our problem. Okay. So from here, we know that these lines are parallel. It's a parallelogram, so or not a trapezoid. So this is 100, this is 100. When I add these up, I know that 100 plus 25 minus 180 is 55. Sorry, I'm going to pause for the pledge.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay. So again, trapezoid, I know that the top and bottom are equal, they're parallel. So if I extend this out, alternate interior angles are both 100. So 100 plus 25 is 125 minus 180 is 55. You actually don't need this 80 at all. I'm so sorry, guys. I could not stop that, and I can't pause my recording. All right, so we're almost finished. We got a pentagon has 5 diagonals instructed below. How many diagonals does a heptagon have? So a diagonal, you just connect the vertices, but you cannot overlap them. So you start at 1. I can't draw on a side, so this is 1, 2, 3, 4. So blue is 4. All right, let me switch colors, make it a little easier. I'm going to hop to this one. So 1, 2, 3, 4. So I'm going to add 4 again. Sorry, I shouldn't have used a highlighter, I guess. Let me try orange. So I'll hop over here. I can't connect that blue because it's already drawn. So 1, 2, 3. There's 3 oranges. If I hop over here, can't connect to here. Can't connect to here because it's already drawn. So 1, 2. Next, I guess I will have to, I'll use this color. All right, so here's a purple pen, a little darker. I can't connect down here or here. but I can't connect to here, but I can connect to here. So that's plus 1. Okay. Well, if I come up here, all of the lines have already been drawn. So that's kind of the limit. I can't do any more because it'll repeat. So 4 plus 4 plus 3 plus 2 plus 1 is 14. So there are 14 distinct diagonals in the picture. It's just a lot of counting. All right. Next one. Number 32. Which of the following is a set of all real numbers x such that x plus 2 is greater than x plus 5? Well, if I try to solve and get my x's together, if I subtract x, I get 2 is greater than 5. Is that a true statement? No, it's not. If it's not a true statement, then your answer is the empty set because it's not true. Now, if it was true, if it said 2 is less than 5, then it would be all real numbers. But since it's not, it is just the empty set because it's not true. Okay, number 33, what is the area of the parallelogram is found by multiplying base and height. What is the area of this parallelogram? Well, this triangle, we know the height and base are always perpendicular, so this is actually a 3, 4, 5 triangle. So the height is 4 and the base is 9. So base times height, 4 times 9 is 36. Option B. Oh, there you go. All right, so for 34, I accidentally labeled 35. These are the same questions, so there is no 35. So to do this question, this is a rhombus, so that lets me know that all sides are equal. Okay. One diagonal is 12. So this diagonal is 12. The other diagonal is 32. How long is the side? Well, we know that rhombi, they intersect at 90. Also, the diagonals cut in half. So this and this are equal. So if I divide 32 by 2, I get 16, which means this measurement is 16 and so is this. Same is true up here. Half of 12 is 6, so this is 6 and so is this. We are trying to find the measure of the diagonal, which is actually the hypotenuse of a right triangle. So I'm going to let me redraw that triangle right here to kind of make it easier. This is 16, 6, and x. 6 squared plus 16 squared equals x squared. When I add those, I get 292 equals x squared. And when I square root, I get roughly 17.09, which is answer B.